Today, I'm going to model a gear in Autodesk Inventor. So this is can also be accomplished, no, by using the Autodesk Inventor assembly design. So from here, I have my Autodesk Inventor. Creating a new file, so I can go back to my assembly here. So for example, no, this can be achieved yung the creation of this Spur gear. So it can be achieved by using the tool made by the Autodesk Inventor. So for example, in this one, in the design tab, so I have my choices here. You will notice here I have my power transmission tab. So in the selection of the Spur gear, so I have different types of gears that can be created. I have my Spur gear, worm gear, and little gear. Now, if I were going to create Spur gear, so the design accelerator says that you must have an assembly document for creating design. So just say the assembly and click OK. That one, so I'm gonna rename this assembly. So I'm just to show you. So this can be assembly 2. So you will notice here in my design, the Spur gears, we have the design guide. So the center distance, how much the distance of the Spur gear, so from the pinion and the drive one. Okay, and we have also the given angle, which is your 30 degrees. So this, you can change that one any angle, so 11, 14, 20, and so on. Then for my other areas here, you have your modules, center distance, gear component 1 and gear component 2. Okay, so this is the one way of creating creating a Spur gears expeditedly. So it's gonna click. Okay, so automatically the design creator of Autodesk Inventor so created here. No? So that is that is the fastest way to create the Spur gears. But I will going to show you is the step-by-step method of creating a Spur gears, which is which is based on the manual calculations. So that is based from the book of Machine Elements and Mechanical Designs by Robert Ermott. Okay, so here. From the book, so we have the step-by-step solutions, how we can achieve to design the Spur gears. Now from the kinematics of the gear, okay, so I have here a sample problem or sample figure here. So what will be the outcome I will be creating this type of Spur gear. Okay, so let's start. I will incorporate also the Excel calculations. I will link the calculated data from the Excel through the Inventor, so that anytime I want to change for example, the diameter of my pinion and my drive gear, so automatically I will going to update my Autodesk Inventors, which follows the data coming from the Excel generated file or Excel entry file, na? So this given data, which is given from the book of your Machine Elements by Robert Ermott et al. So we have the given data for the diametral pitch, so that will be 12, and the number of teeth, which is the pinion, so that will be the gear drive. So we have the given, which is 12, and the number of teeth or gear drive, so that will be 18, and the pressure angle is 20 degrees. Now to calculate the diametral pitch of the circle for the drive pinion gear, so we shall be using this equation, no? That is PB. No? So that is equal to the number of teeth divided by the pitch diameter of the gear And we can rewrite this one in terms of my drive pinion, so that will be number of teeth for my drive gear and the pitch or diametral pitch. So that will be equating that one, your equation, so that will be NP. So that will be 11 divided by your PD. So which is my diametral feature. So from here, so you will notice here the equation NP, so that will be 11, divided by diametral pitch, which is your PD dot. So then entry that one, that will be equal. Then I will type the round my data, or round of my data into 4 decimal places. So round that one, then slash comma, that will be comma. Then we have 4 digits. I'm gonna press enter here. This one, enter that one. So I have 0.9167 inch for my diameter pitch. Then I'm gonna convert this one. So I'm gonna put here a conversion. So from inches to a millimeter. Okay. So again, 4 decimal places round up. Now the same also that I will be using to calculate the diameter of the pitch circle for the driven gear. Okay. So we have the equation, so the number of teeth divided by the pitch diameter. So rewriting my equation here, so that will be my drive gear DG for my diameter of the pitch circle for my driven gear. So that will be equal to the number of teeth of the driven. So we have here 18. So that will be divided by the diameter of pitch. So round this one. So when I round this one to 4 digits, and press enter here. So I have the value of 1.5. So the unit is inch. And then I will make a conversion for this one. So move this one here, and this will be equating to 1.5. So change to mm, and round it in 4 decimal places. So I have 38.0999 for my mm. Now calculating the circular pitch for the drive pinion of the gear, we have this equation, so that will be P, so that is equal to pi dP, so your dP, so that will be the diameter of the pitch of the circle, and divided by the number of teeth for my pinion drive. So enter here, we're going to equate that one, so we have your pi, so close parenthesis that one, then asterisk, so multiply by the value of your dP, so diameter, so that will be 0.91 inch. So in terms of inch, so I'll be using the terms of inch unit. Then all over, so gonna divide all over. I'm gonna divide this one by the number of teeth of my pinion, so that will be 11. Okay. And so I have to round up. So I'm gonna round off my number decimal values here for 4 digits value. So then just press enter. So I have a value of 0.2680. So again, I will be adding my conversion here. So just to have a conversion value for my circular pitch. So every time I'll be using that one, so that I can easily adapt that one in my model. So I'll be using an mm for my modeling in AutoTest inventory on this one. Then for my circular pitch for my drive pinion, so the same equation that I'll be using here. Okay, so that will be your 5dg. Okay. So I'm gonna type here again, copying on this one and touch it here. Then for my pitch diameter, that will be your T20, and for the number of teeth for my drive, so that will be 18. Okay. Then the DG, so that is the same, that is 1.5. So I'm going to press enter here. So I have a value of 0.2618. So that is in terms of inch. Again, convert this one into an mm values. So, then bringing down here the table 8-4 formulas for gear tooth features for 20 degrees pressure angle. Okay. So we have the corresponding feature here, addendum, dedendum, clearance, and we have your symbol, coarse pitch, fine pitch, and metric and module. Now, referring to the table 8-4, so for my A, which is my addendum, so we have here the coarse pitch. So we have here the diameter, PD. So my PD here, so coarse pitch, if my PD is less than 20, then referring that one, my PD or diameter pitch is less, so it is less. So we'll be using this value. So that will be 1 over your PD. Okay. And this one, I will gonna equate this one into the equation. That will be 1 divided by PD. So PD is 12, and close parenthesis on this one, and round off the values to 4 decimal places, and press enter, and we have the value of 0.0833 inch. Then for my calculating the addendum, again, so referring to the table, again, this is less than your diameter pitch, so we'll be using 1.25 for your E for the diametral pitch. So we can use this one, so this is the equation, okay. So that will be equal to 1.25, sorry. This is 1.25, then divided by the diameter pitch, where my diameter pitch is 12. Okay, then round off my answer here into 4 decimal places. Then for my addendum, so again, so we'll be putting the round off value here per digit. Okay. And for my conversion, so the units here is in terms of inch. Now for my conversion here, I'm gonna put the values here for my conversion: 2.64, 64, and 67. So this is also a 4 digits one. Okay. Then so next will be calculating the clearance, again basing the table 8+4. So for the clearance, that will be 0.25 divided by your PD. So using that one, 0.25, then my diameter pitch, PD, so I have my 12. Okay. Then the close parenthesis of this one, and give a round of make the round of string to 4 digits, so 4 digits number, 4 decimal places. So one, so enter. We have 0.0208. Okay. And the units here is in terms of inches. So next, we'll be calculating the outside diameter of the pinion. We have this equation, so that will be your NP, so number of teeth my pinion, then diameter of pitch, so that will be plus 2 over 1 over your diameter of pitch. So this is from the book. rubber element, so this is prepared for the accuracy. So I'm gonna equate this one, so this will be close parenthesis of this first term. Escape that one. We have the number of feet of my pinion. So from here, going back upside from the top, so we have the number of feet of pinion, number 11, and it's missing the identification. Then I'm gonna divide this one by diametral pitch. So the diametral pitch, we have your 12 PD, and next I'm going to add that one. Change this one back here. Then I'm gonna add here the close parenthesis of the second term, so that will be 2. So master H times close parenthesis of that one. Go back, escape. Then we have 1 over your PD, so the diameter pitch. So this one. Okay. So I have that one ready. Okay, so you can then go back, and we have this one from close parenthesis of that one, then enter. So I have outside diameter of 1.083. Then again, so using the round off string, round off my values to 4 decimal places, so close parenthesis on that one. Then I have 1.003. And my unit is in terms of inch. Okay. Now I want to convert this one in terms of mm, so just copy that one, bring down here and move my data to this tab. Okay. So for that, then I have my 27 mm for my values for my in terms of So round off, we have 4 digit, round off for 4 decimal places. Escape that one and click save on this one. Now for my driven gear, so the same equation that we'll be using. So again, the number of feet for my driven, then divided by the diameter of pitch. So plus 2 over your diameter of pitch. And then we have the number of feet for my driven. So going back from the top, we have your 18 here. Then divide this one by PD. For my PD, I have my 12. Then I'm gonna close parenthesis on this one. Then add plus sign. So close parenthesis for the second term. So we have 2 times the close parenthesis for that values. So we have here 1 over my N8. So that stands for my BD. So N8. Here N8. Then we have here the equation. So I'm going to press enter. So I have 1.66. Then I forgot to put my round of strings here. So okay, then comma here 4. Okay, so I have my 1.66 in terms of my inch. Now I want to convert this one in terms of mm. So, okay, so the same also that we have here. Just copy that one. So I have that one. Save that one. Now calculating the root diameter of my pinion, so we have here the equation, the root diameter, so that will be the diameter of pitch minus your 2b, and we can enter here the values, your dp, so the diameter of pitch values, that will be in terms of inches. Okay, so we'll be using inches here, 0.167. Then minus that one, that will be 2 times the value of your B, which is the dedendum. Okay, so again, the value is in terms of inch. So close parenthesis on that one. So I have here the values for my root diameter. So I'm going to copy this one units and place it here, and this one, copy that one also for my conversion. So 17.907, and this one is 0.78. 83. Okay. Now next, calculating the root diameter of my gear, or my driven. Okay, so we have the equations, so the same equation that we'll be using. So that will be equal to my DG. Okay, so yeah, that will be my diameter pitch circle, so that will be 1.5 inch. Then minus that we have here 2 times the value of my B. So the same value of your B for my dedendum, so that will be 0.1042. Using that one, close parenthesis. So I have 1.2916, and copying this one, placing it here, and this one, and placing it here. Okay, so I have now for my root diameter for my pinion and my drive gear. Now for the whole depth, so it is represented by symbolized by HT, so that is equal to A plus B. Okay, so it is simply adding your addendum and dedendum values in terms of inch. So 0.33 plus the values here for my B. Okay. So that will be my value for my whole depth. So copying this one here. And for my conversion, so this one in here. Now in terms of the working depth, okay, so we have the equation that is 2 times the A. So I have here 2, that we asterisk times the value of your A. So again, that will be the addendum in terms of inch. So close parenthesis this one. And give it a round of values for my close parenthesis, and round of values here for 4 digits values, or for decimal display of decimal places. Okay. So I have 0.161, so that will be in terms of inch. So I'm going to copy this one and my conversions in here. Okay, now for my tooth thickness, so that will be T, that is equal to pi over 2 and divided by over 2 times the diametral pitch. Okay, so we'll put my pi here. So that will be equal to pi, close parenthesis on that one, then close parenthesis on this side. One, that will be 2 times my diametral pitch. We have your TD. It will be 12. Okay. Then close parenthesis to give the decimal places here, round up to 4 decimal places, and press enter. One. So I have 1309. So this is in terms of my inch, and convert this one into mm. So I have my tooth thickness. Now for my center distance, so that will be the number of teeth of my driven gear plus the number of teeth of my pinion divided by 2 times your diametral pitch or circular pitch. So I'm going to equate this one. So we have NG, so the number of teeth of my gear driven, so that will be 18, then plus then the number of teeth of my pinion, then close parenthesis on this one, so close parenthesis on that one, so then divide, so that will be 2 times my TD, so close parenthesis on this one, and 2 times my, using my TD. So my TD here, so we have the diameter. Okay, then I'm gonna round this one in decimal places to 4 digits. So then put here 4 and press enter. Then I have the value which is 1.2083. So the units here is inches, And for my conversion, here that is 30.690807. Okay. Next, we have your base circle. Base circle for my pinion diameter, pinion gear. Then we have this equation, so that will be the diameter, which is equal to the diametral pitch dp, so times the cosine, which is your theta, will be the pressure angle. So which is now equal. So equal string. So we have to locate the value of your dp. For the value of dp, so we have in terms of inches for my pinion gear. So then this is going back to my equation, that this is multiplied, this multiplied by the cosine of the pressure angle. So I'm gonna close parenthesis on this one, then cosine of the angle or pressure angle, we have 20 degrees, so that will be 20 degrees. So cosine, replace this one, cosine of 20 degrees. Okay. Cosine of 20 degrees. So going back to the equation there, I'm going to press enter here. So you will notice here what we are getting. We need to convert this. Our angle here must be converted into a region, okay, or the value of the angle must be converted into region. So what I'm going to do is double click this one. So I will click here. I will type a string here, region. So I'm gonna click here, region. Close parenthesis on this one, region. Convert this one in terms of regions, so that we can get the values of your diameter. And we forgot to write here region with S. So press enter. Then we have the angle 86.1416. So I'm gonna round off this one to 4 decimal places and enter. So I have 86.4. So this will be in terms of inch, and convert this one into mm. Okay, so we have 21.8795 for my base circle for my pinion. The base circle diameter for my driven gear. So I'm just gonna copy this one, hold this quick, whole value of this one, then I can relocate the values for my theta and also for my dp. Okay, so my dp, so this is will be my pressure angle. Okay, and so for my S20, this will be my, so that is the angle. Then going back to the equation, so let's just enter. So for the S20, so that will be the diametral pitch. So again, I will be using your DP here. So note that will be the DG. Okay? So we have the diameter, the pitch diameter of the pitch circle for the driven. So that will be 1.5 and that one. So I have 1.409 so in inch, and as a value of 35.801 for my conversion in mm. This is for the base circle for my driven gear. Then next we have to determine the circular thickness of the pinion. So that is 360 divided by the number of feet of my pinion times 0.5. So 360 divided by NP. So let's try to locate the value of NPM, number of feet of my opinion, so that would be 11. So entering that one. Then this is 4 close parenthesis multiplied by 0.5. Then I have to round off the decimal places, or the decimal places. How many values is? We have 4. We have 16.366. I'll start my Autodesk Inventor Professional 2020. I will be starting my new part here, part 5. So I am in a folder of my Spur gear folder. So I will be starting my origin here for my XY plane. So I'll try to draw a sketch here. Okay, so initially here. Then what we have to do, so initially, so we have here the data that already. Okay, so if we go back to the figure here, so what we have is we need to draw first so this outside this circle. So it is also, this one is the root diameter, and we have your diametral pitch, or DP, and we have your outside diameter. So we can start draw the root circle for my pinion. So looking here from my calculated data for my root diameter of my pinion, so I have a 17.9907. So that is in terms of my mm. Now go back to my Autodesk Inventor sketch. So I will be drawing here starting my sketch at the center point. So this will become my root circle. So I'm gonna give this diameter. Okay. So I'm gonna temporarily check this one. Then what I'm going to do is to import. So so go to your Manage tab. Then from here I have the parameters. So double click the parameters. Then from here I'm going to click my link. Then I'm going to select the Excel file, which is a Spur gear calculator. So it will be my revision 1. So you will notice here in my tab is that we have here the link. Okay. And the link data that will be read by the Autodesk Inventor to read the data it will be started from the A1. No? And if you will go back to my for this Excel file, so when you say A1, so anything that starts here, okay, so the Autodesk Inventor will read the values. Okay. Now I will try to link that one. Then I'm going to open that one. So open it. Then says that the file in which you're placing this component has not been saved, so may cause problems in solving the links between files, and click OK. So still we need firstly to save the part file. So I'm going to click my part file. I'm going to finish my sketch and save this one. So I'm gonna rename this one as a pinion gear +1. Save that one. Then I will go back to my sketch. So you will notice we need to link that one. Then from my this one. So I will be typing a root diameter, so that will be equal to the value of my root diameter. So this one, and I'm gonna type here. So since it's the diameter, so I'm gonna rename this as a D root. So root D, so that will be for D stands for root, the diameter, and root, and let's say opinion, to distinguish it, what type of root is that one, if it is a pinion or a drive gear. Yeah. Then on the other side, so I will enter here the value of my root diameter that I'm being calculated before. So I'm going to look for the root diameter, which is 17.907. So this one, and in here I'm going to put the units here for example. Then I'm going to save this one. Then from going back to this inventor screen, then I'm going to update this one. So clicking this one, this plus lightning symbol. So it will be updating. Okay. Then clicking my dimensions here, you will see the list for we will go to the list of parameters. So you will see there that there is a root pinion. So click that one, then enter. So you will notice that my diameter changes, which is now equal to the diameter of my entry or calculated data from my Excel. So that is 70.9907. Okay. And if I will try to change my diametral pitch, so for example, I want to change this one 11. So you will see that that is 19. So I'm going to save that one. So that is 19.629 mm. Then going back to my Autodesk Inventor, so you will see here that the lightning symbol also highlighted. So it means that we need to update. So I will click on this one to update. So you will see here my sketch follows the local update, and also as I updated my data from my Excel file. Okay. So what I'm going to do is I'm going to bring back the size here to the value of 12, and click save file, and go back to my Autodesk Inventor and update that one. So it is 70.9191. Okay. Then next, we're going to create the outside diameter. So from the circle, from the center, so we have that one, center of my circle. So I'm gonna give this diameter. Okay. So this is for my outside diameter of my pinion gear. So outside diameter, if we're going to look, so it is here, outside. So outside diameter of my pinion gear. Okay. Then here, so I'm gonna copy this one, and I'm gonna rename this one. So diameter, which is outside. So outside, just only to distinguish. So diameter outside for my pinion. Then adjusting, so let me adjust this one. So looking for the values for the outside pinion, so let's try to look for the values of this one. So, and outside pinion, we have for my outside diameter for my pinion, okay, we have this one, 27.5157. Okay. So enter that one. So I have here the units again, so that will be my mm. So I'm going to save this one. Then go back to my Autodesk Inventor, update my local update here, and clicking this the dimensions. So clicking this greater than symbol. So this the parameters, and my outside pinion diameter of my outside pinion. Okay. Then click on that one. Okay. So you will notice that it's 27.516. Okay. Then I'm gonna turn this circle into this dotted line. So since this is this serves as my guide, and
for my ears. No? Then next I will going to draw, so from the center, I'm going to draw another circle here that will serve as my this one, DP, or the pitch diameter. Okay, so that will serve my pitch diameter. Then this is my pitch diameter, giving this diameter dimensions. And click this one, and I'm going to put a text here so that I can remember, or this will serve as my guide. So I'm gonna give this the name. I'm gonna type here root diameter, so that it will serve as my guide every time I will try to look. So what type of circle that I've been drawing, or what I got, that will truly guide me. So I'm going to change the size here 2.224, and at least maybe around 1. Okay. Just 0.8. 0.8. Still, it's more. 0.5 will do. Okay, so 0.5 will do. Just this one, so that it will not confuse my sketch here or disturb my sketch, and also will not interfere with my sketch. And I'm going to copy this one. So this is my outside diameter. You click, so you can change that one, so it will be outside diameter, and click OK. Then this one is my pitch diameter, and let's go back to my Excel file. So going back to my Excel file, so for my pitch diameter, or calculating the pitch, first we have here the diameter of the pitch circle for the drive pinion, PD. Okay, so name here D outside, D pitch, diameter of the pitch for my pinion, and equating it to the value of this one. And the same also here. Okay, so for my MM, so click Control Save. So to save the Excel entry. Then from here, my output decimeter, so I'm going to click my local update. So it means that the data that is being linked is updated. Then for my pitch diameters, so double clicking the dimensions values here, so these parameters, so I have now my pitch pinion, so click that one and click the check button, and we have updated already our pitch diameter. And also I want to turn this one into a hidden broken line. So this means that this is my guides from pitch diameter and my outside diameter. Then next, let's proceed of creating my circular thickness. Circular thickness, I'm going to name here circular C thickness. So thickness, and right here pinion. I gave the name pinion to distinguish. And for the value of my circular thickness, so I'm going down here, and this is an angle. So circular thickness is degrees. Okay, so this is an angle. Okay, so for my circular thickness, so I will be drawing a line. So take my line here. Now on the center of my circle, so I will draw a line here.
And I want to check this one as a broken line, so this will serve as only my guide. Okay. So please escape. Then I'm gonna give a distance for this one, or angle. So not a distance but an angle. So you will notice here I don't have the reference, but I will be highlighting my y-axis and make it visible so that it will serve as my reference. So make this one also a hidden line. Okay. Then giving the angle dimension, so from my y-axis, so I have 23.89, so click that one, then list. I have my circular thickness of my pinion. Now, so click that one and click OK. So we have here the angle. Then going back, so take note, the units of my circular thickness in pinions, so this is in degrees, so the units must be also this symbol or in this word, so degrees. Okay, so that the autodecimeter will read it also a degrees, not an mm. Okay. So going back, so I have my circular thickness now, so I want to divide this one. So again, I will be drawing a line. So it's also a hidden line to divide this tooth, base of my tooth. Then base reference of my tooth of the gear. So I'm gonna give this an angle. Then I'm gonna make here an equation that will be divided by the value, no? The value of this one, then divided by 2. So I have now the section, the half section of my circular thickness. Circular thickness in pinions, so this is in degrees, so the units must be also this symbol or in this word, so degrees. Okay, so that the autodecimeter will read it also a degrees, not an mm. Okay. So going back, so I have my circular thickness now, so I want to divide this one. So again, I will be drawing a line, so that is also a hidden line to divide this tooth, base of my tooth, then base reference of my tooth of the gear. So I'm gonna give this an angle. Okay. Then I'm gonna make here an equation that will be divided by the value, no? The value of this one, then divided by 2. So I have now the section, the half section of my circular thickness.